Hi, I'm Megan.
And I'm Krista.
We're two nerds getting our PhDs in chemistry, and we started this channel to explain the science behind things that you see every day.
So please like, comment, and subscribe to check out more of our content, and thanks for joining us on
Explained by Nerds
with Megan and Krista!
In this episode, we're talking about the science of sunscreen.
Yep, this stuff.
Ooh. You know what they say, sun's out, guns out. Ugh.
It's springtime in Southern California.
SoCal.
Which means we like to go outside and play in the sun. But we have to protect ourselves.
Right, so in this episode, we're going to talk about the science of sunscreen and how it works, but also how it's having unintended consequences for our environment.
What is it made of? What is SPF? How does it protect us from burns? And how does it affect the oceans?
And stay tuned for the end of the video where we do a cool demo to see if differences in SPF actually matter. Before we talk about what sunscreen is, let's cover the basics of why we need it. Fundamentally, we need sunscreen to protect us from exposure to too much sunlight. The sun emits energy as light. These pieces of light are called photons. Photons have energy, and they also have a wavelength, which we describe as lambda. The wavelength determines the energy, and different wavelengths of light are classified into different groups. The sun emits different types of light.
The different types of light this includes are ultraviolet, or UV, visible, which is also known as vis, and infrared, which is IR. But since we're talking about sunscreen, we're going to focus on ultraviolet or UV light because that is the one that actually damages our skin and our DNA. So you can classify it as two different types, UVA and UVB. So UVA ranges from 320 to 400 nanometers, while UVB ranges from 290 to 320 nanometers. That's really tiny, really, really small. So that means it has a very high energy because it has a very short wavelength or lambda. UVA actually penetrates much more deeply into the skin and is what causes most of the DNA damage.
About 95% of the UV light that we experience on Earth is UVA, and the other 5% is UVB.
Excuse me, Megan. Your math is wrong. You forgot UVC.
Well, you see, the ozone layer is actually Earth's sunscreen in terms of UVC. It blocks out all of the UVC that comes from the sun, so we don't experience it.
Oh, I see. My apologies. Sunscreen or sunblock can be made of a few different ingredients. There are chemical ingredients and then there are mineral ingredients. Chemical ingredients are made out of carbon and are considered organic. Mineral ingredients are made out of metals and oxygen. They are considered inorganic because they do not contain any carbon.
The organic molecules absorb the UV light, while the inorganic molecules reflect it back or scatter it.
Some sunscreen products have one or the other or a combination of both. Some people think they're bad for you, but these ingredients are safe for us.
Here are some other examples of organic sunscreen components and inorganic sunscreen ingredients, like titanium dioxide and zinc oxide. They protect us from different types of UV light, and that is nice. Although these ingredients are safe for us and they protect us from sunlight, they aren't necessarily good for our ocean friends. We'll get to that in a bit.
Yes, stay tuned to hear about how we can help protect our ocean buddies, because remember, fish are friends and food.
Krista, it's fish are friends, not food.
Try telling that to my cat. Anyway, Megan, please explain why reflecting and absorbing light is important for our sun safety.
Well, these molecules and the damage that they prevent are the keys to eternal youth.
So, fun fact about Megan, she loves sunscreen. She reapplies it constantly when we go to the beach, and for good reason.
And I always buy the really high SPF, like 70.
So tell me, why do you like to buy higher SPF and constantly reapply?
Higher SPF helps prolong your time in the sun without getting burned. For example, if you wore no sunscreen, so SPF 0,
you would burn in 10 minutes.
Raisin head, man. Bad.
If you apply SPF 30, you could be in the sun for 30 times longer without burning, so 300 minutes. However, that doesn't protect you from 100% of the UV radiation, and it doesn't actually last that long. You should reapply your sunscreen every 2 hours to help prevent damage to your DNA.
Does this DNA damage last forever?
Yep, forever. How does that actually happen? It can either change the types of bonds that are occurring between the two strands of DNA, or it can put bonds in the wrong places.
This is bad because it can lead to cancer, premature aging, and don't forget, raisin face. But don't worry, as long as you use sunscreen, you won't look like a raisin face or get cancer or premature aging. Unfortunately, although sunscreen protects us, it is bad for our ocean buddies.
There are quite a few studies that show how some of the key ingredients in sunscreen can do things like bleach coral reefs or cause problems for certain animals in their reproductive cycles. And currently there are no known sunscreens that are completely safe for the ocean. However, there are some things that we can do to kind of protect them from certain ingredients and also to limit the amount of sunscreen that we put into the water.
Yeah, especially when we're at the beach and we're going in the water, we're reapplying, we're not waiting long enough to go in the water, and then it all just washes off into the ocean.
So some things that you can do are look out for types of sunscreen that exclude certain ingredients, but keep in mind that although there might not be studies that show that the other ingredients are dangerous, the molecules are similar, and so they're probably also bad. The other thing that you can do is just wear layers of clothes like that sun protecting type of material to limit how much sunscreen you have to put on, and avoid being out in the sun too much during the hottest hours of the day, which are 10 a.m. to 2 p.m.
Stay safe.
Here's a list of some ingredients that have been shown to do damage to different parts of the ocean. Reef-safe sunscreen is normally just missing oxybenzone.
While many companies will try to sell you on non-nano size titanium dioxide and zinc oxide, they are all technically still very small and can get into different creatures in the ocean. The particles are still nano, under the true definition of what makes something a nanomaterial. Some companies will tell you about the size of their particles, but not many of them do. You would want to aim for things in the micron region.
Now it's time for an experiment. On a kind of cloudy day, we decided to compare 3 different types of sunscreen. We used UV responsive beads, which go from white to colored when they interact with UV light. Next, we coated them in sunscreen. One is SPF 30 and it's reef safe, so missing just one bad ingredient. One is SPF 30 beach defense, so it stops the ocean water from washing off your sunscreen. And one is SPF 70 beach defense. We took those coated beads and also had a control with no sunscreen and exposed them all to the sun. Ooh. As you can see, the no sunscreen beads become colored right away. And having some sunscreen, even SPF 30, helps to protect the beads from sunlight. The 2 brands of SPF 30 were pretty different in how much they protected from the sun. The other thing is that even though the sunscreen helps to protect the beads, some of them, especially the purple ones, are still exposed to UV light. So even wearing sunscreen isn't enough to completely protect you.
Thanks for joining us today and learning all about sunscreen.
Woo, woo, woo. Stay safe out there, protect your skin, and do your best to protect the ocean. And most of all, have a good summer.
Nerds out.
We're inside.